full of computing. So we often talk about technology as the key to our future, but we rarely talk about the cost of that technology on our planet. Today, I am to explore how we can balance computing with environmental responsibility. So how we can define green computing, we can say designing, using and disposing of computers with minimal environmental impact. So it is not just about turning off your computer. It is the holistic study and practice of using computing resources efficiently. And we are looking at the triple bottom line, balancing people, planet, and profit. So our goal is to answer a critical question: how do we maintain our technological progress without exhausting the ecosystem that sustains us? So, talking about a brief history of green computing isn't a brand new concept. It really began in 1992 with the introduction of Energy Star by US Environmental Protection Agency. And you might have seen that this logo, Energy Star logo, in your computers. So it identifies energy efficient products to reduce greenhouse gas emissions and consumer cost. However, as the internet exploded in the 2000s, power consumption can say skyrocketed. So today the focus has shifted from just saving energy to net zero, carbon neutrality, and circular economy, where nothing goes to waste. So let's look at the numbers. Currently, ICT accounts for about 3 to 4% of global carbon emissions. So to put that in perspective, that rivals the entire aviation industry. And we know that unlike aviation, which fluctuates, digital demand is only going up. So if we don't change our methods, this footprint predicted to triple by 2040. Then there is the physical waste, e-waste. So we generate over 50 million metric tons of e-waste every year globally. Think about how often you change your phone. Every 2 years, maybe 3 years. Because of this rapid obsolescence, we are discarding devices at a higher rate. And sadly, much of those ends up illegally dumped in developing countries. When we talk about plastic or the e-waste, it's not just plastic sitting on a landfill. No, it's huge amount of toxic materials. So computers are complex chemical cocktails, we can say. So we are talking about lead, mercury, cadmium, and flame retardants. When these are dumped improperly, they leach into groundwater and soil, creating severe health hazards for the local populations where these wastes end up. Then if we talk about the product life cycle, so most people think that the energy acts of a computer happen when it's plugged in. Actually, a massive chunk of the environmental damage happens during extraction and production, mining rare earth minerals like cobalt, lithium, and fabricating chips requires large amounts of water and energy. So by the time you buy a laptop, it already has a significant carbon debt. And now let's talk about some solutions. The green data center. It starts with, like we can say that traditional centers use massive air conditioners. No, you may have seen that our NOC, no, the network servers. They are with massive air conditioners. So green centers use free cooling using outside air or liquid cooling systems. Some companies like Facebook even have built their centers near the Arctic Circle to let nature to do the cooling for them. AI is also helping regulate these temperatures in real time, that means regulate automatically. Another solution is using cloud computing strategy. You know that cloud computing lets you access scalable, reliable, and cost-efficient computing resources without needing to maintain your own hardware in your premises. So it reduces overall energy use and carbon emissions by running workloads on highly efficient, optimized data centers. Then we can't forget about green coding, because hardware isn't the only culprit. Software matters too. Green coding is the practice of writing efficient code. Bloated code, we can say, makes the processor work harder, which drains your battery. It will drain your battery faster, and it will lead to more frequent charging. So efficient software literally saves energy. Then about hardware innovations. We know that hardware is evolving. We can see the processors, high performance per watt processors, and also storage devices. They are moving from hard disk drives to SSDs, and screens moving towards LEDs screens. Then about power management, OS control of hardware power, and to use wake on LAN servers, and undervolting, that means reducing the voltage to reduce heat without losing speed. Also, there are certifications and eco labels. I'm sure that some of you who do the procurement are familiar with this. So for procurement, look for the labels. Energy Star is the baseline, and EPIT is a comprehensive global rating system. TCO certified looks at sustainability. So if you are buying hardware for your department, these certifications will guide you in buying the hardware. And also, right to repair concept is a major cultural shift is happening now, and manufacturers have, we know that, holistically made it difficult to fix devices using proprietary screws or gluing batteries down. So new legislation is forcing companies to make parts available. So if we can extend the phone's life from 2 years to 4 years, we have its environmental impact. Again, there are emerging technologies, DNA storage, storing data in biological molecules. So there will be zero maintenance energy, and optical computing using light instead of electricity, and biodegradable electronics. So that will dissolve the circuits will get dissolved. So another actionable steps that we can take, no, individuals can use dark mode, unplug unused devices, delay upgrades, and cooperate, audit PUE or power usage effectiveness, migrate to cloud, start recycling programs. Procurement, we can buy certified products. So, so in conclusion, we can say we must change how we use technology, and sustainability is the foundation of future computing. Also, I need to talk about vampire devices here. You have to unplug vampire devices. That means devices that suck power when off. So that is a good way of saving energy. I would like to finish with this. So, how many of you have got good morning pictures today? Right? You know that this picture looks harmless, but digitally it is heavy. So, sending that one photo generates roughly the same carbon emissions as sending 300 text messages. Imagine. So, also now imagine that this photo being downloaded by 20 people in a group, we are creating a massive carbon footprint even before we start our day, right? So think about it before sending a good morning picture to your group, WhatsApp groups. So